Alright, boys and girls, welcome to our very first video lesson in Chapter 10. We're now going to embark upon our exploration of the extraneous and idiosyncratic circles. Okay, let's go. Okay, let's review a couple words real quick. Things you should know. This line right here, AC. This line right here, AC. A line that goes from edge to edge of a circle through the center is called the diameter. And you know that. BC, this line right here going from center to edge of a circle is called, of course, the radius. Plural of radius is radii. Segment DE going from edge to edge. It does not have to go through the center, but any line that goes from edge to edge of a circle, of course, is called a chord. Sometimes we'll call it chord just for the fun of it, but it's not a chord, it's a chord. Okay, the formula for area of a circle is pi r squared, and you know that. The formula for the circumference of a circle is 2 times the diameter. I'm sorry, 2 times pi times the diameter. I'll just write it down. The circumference of a circle is 2 pi r, 2 times pi times the radius, or of course, because the diameter is 2r, pi d. Okay, a couple more words you need to know. Concentric circles. These two circles right here, this circle right here, and this circle right here. These two circles are concentric because circles that have the same center are concentric. So circles that have the same center. Congruent circles are circles that are the same size and shape. All circles are the same shape, so all circles are similar, but congruent circles are same size as well as same shape, and you can measure any piece of a circle. Like for example, these two radii are both 5, so these are congruent circles. And you know these words, but interior, the interior of a circle is the inside of a circle. The exterior of a circle is outside of the circle. And the circle itself is just the edge. It's just the edge. So the inside of the circle is not on the circle. It's on the interior of the circle. The circle itself is just the crust. And outside the circle is the exterior. Okay, arc length. We did something similar when we were finding the area of sectors. Okay, but an arc length is the distance between endpoints along an arc. So if I have a circle, the arc length would be a piece of the circumference of the circle. So this green piece right here would be an arc. Its arc length is the fraction of the total circle compared to the circumference. So we did what we did before when we had sectors. We're going to take the measure of the circle divided by 360 and multiply that by the circumference, pi d, and that's going to give us our arc length. Okay, so we're going to find the arc length here of arc AB. That's this arc right here, arc AB. That would be this length right here. How long is that? Well, we know we have the circumference, or we have the arc measure of 120 over 360. That's the total circle, times the circumference of the circle, which is 2 times pi, times the radius, which is 4. Okay, 120 over 360 we know is 1/3 of our circle, so it's 1/3 times 2 times 4, which is 8 pi. So our arc length is 8 pi over 3. There we go. And one more problem here. If the length of AC is 16 pi meters and AC is 120, what's the radius of the circle? So again, we can see we have an arc length AC right here. That's equal to 16 pi. We're looking for the radius. That's this length right here. That's our R. And we know the measure of our arc is 120. So again, we're going to go 120. We're going to go, well, let's do arc length. So arc length is equal to 120 over 360 times 2 pi r. Okay, well, let's put in our numbers. Our arc length is 16 pi. Our angle was 120 over 360, which of course is 1/3, times 2 pi r. R is what we're solving for. Let's do some canceling. I'm going to cancel the pi's right here. I'm going to cancel a 2 and a 16, and that's going to become 8. So now I have 8 is equal to 1/3. 120 over 360 is 1/3 r. I'm going to multiply both sides by 3 times 3 times 3. The 3 and the 1/3, they cancel. So I have r is equal to 3 times 8, which is 24. Hey, that's it. Short and sweet. Circles, circles, circles. We'll see you soon. Adios.